The focus of this video is to revise how to balance a redox equation in an acidic solution. A redox reaction means one of the reactants is reduced and the other one oxidized. Oxidation could mean oxygen gain and reduction could mean oxygen lost. So in this case, the aldehyde with an oxygen, so we just put a square bracket O to represent oxidation, becomes a carboxylic acid, so that's oxidation. An example of oxygen loss for reduction, so copper here was copper oxide and it became copper here, so this is reduction. Oxidation could also mean loss of hydrogen, so let's compare this alcohol with this aldehyde. So there are 1, 2, 3, 4, 5, 6 hydrogens here. 1, 2, 3, 4 hydrogens here. So hydrogen was lost here. So this is oxidation. And hydrogen gain is reduction. For example, this ketone, if you add 2 hydrogens here, it becomes a secondary alcohol. That is reduction. Oxidation could also mean loss of electrons. So look at the zinc here. So it loses 2 electrons here, so that's oxidation. And copper, it received 2 electrons, so that's reduction. So this is actually very much related to the change in oxidation number. Except this change in oxidation number would also apply for things that are covalent. And the way we calculate the oxidation number, we would treat it as if it was ionic. Let's look at the oxidation number in chlorine here. So there are 6 pieces of chlorine here, and each of them are in oxidation number of 0. 1, 2, 3, 4, 5, 6, all zeros. Okay, on the other side, there are 5 Cl minus here, so -1, -1, -1, -1, and another -1. And there is just 1 Cl here, and let's count its oxidation number. So each of this oxygen would be -2. There are 3 of it. You don't know what Cl, and Na is +1. Equals to 0, as in no charge here. So X is +5. So we treat as if this was ionic, but it's actually not. So these are all the positive ones, and oxygen are the negative ones. So 5 of the chlorines received electrons or changed in oxidation number here from 0 to -1. So they received electrons. Electron gains means reduction. And 1 of the chlorine got oxidized because it threw out 5 electrons. So oxidation. So that's how you figure out which one got oxidized and reduced when there's a change in oxidation number. And this oxidation and reduction happen both for chlorine, so we do call this a disproportionation reaction. Let's figure out some of the oxidation states or numbers here. Say SO2, so each of the oxygen would be -2, and there's 2 of it, plus sulfur, which we don't know, equals to 0. 0 as in there's no charge here. So the X would mean it is +4. That is its oxidation state or number. Let's try something like this with a charge. So X, not sure what's the sulfur, plus 4 of that -2. We would get -2 as in this. So X would be +6. Okay, PCl3. So P here, let's say we don't know. So X plus 3 of the -1 will get 0. So X equals to +3 here. We would name that phosphorus 3 chloride. So the Roman number represents its oxidation state. Okay, our focus. Let's balance this redox equation that is in an acidic solution. So the two half equations, so we know that there's Fe here, so I'm going to break it down to two half equations. Okay, so I broke it down. So I took Fe2 and Fe3 here, and the rest of it, acidified dichromate, I wrote it here. Now let's balance all the atoms except the H and the O. So each one separately. So the Fe is already balanced. The other one, there's two CRs here. Okay, I've taken care of the CR, but I didn't bother about the H and the O yet. Next, add water to the side that doesn't have enough oxygen to balance the oxygen. Again, there's no changes here. Okay, so on this one, we're going to add water to the side where there's not enough oxygen. So here there's 7 here, and there's only 1 here, so we need to balance this. So I put 7 water here to balance the O. Okay, next is we're going to add H plus to the side that doesn't have enough hydrogen atoms. So again, this equation for Fe is not disturbed. So the other one, we have to balance the H now. So 7 times 2 would mean 14 H plus. Next, we're going to add electrons to the side deficient in negative charge. We're going to balance the charge this time. So it's 2 plus on this side and 3 plus on this side. So I will need an electron to balance this to make both sides 2 plus. So Fe2 plus and Fe3 plus with an electron. For the other side, negative 2 plus 14 positive equals to positive 12. So this one there is positive 3 times 2, I will get positive 6. So in order to make this become positive 6, I will need 6 electrons. Next, we're going to cross multiply the electrons. So there's 6 here and there's 1 here. So multiply by 6, the whole equation. So don't just multiply the electron, but the whole equation. And on the other side, since there's 1 here, I'm going to multiply 1, which is the same. Okay, so I'll rewrite that here as 6Fe2 plus. It becomes 6Fe3 plus 6 electrons. The other one is still the same. Always make sure that in one equation, the electrons appear on the right, and on the other one, the electrons appear on the left, because it means that one threw out the electron and the other one gained the electron. So redox has to be like that. One gives out the electron and the other one accepts the electron. So we're going to cut that off. And we'll copy the rest. We'll copy everything on the left. And we'll copy back everything on the right. Oh, just this. So that's everything on the left. And let's copy everything on the right. And there you go. Now it's balanced.